Good morning. It's March 12th, and this is your daily brief in science. Here's everything you need to know. A measles exposure event has been reported in Washtenaw County, including Ypsilanti and Canton, with cases linked to several local locations from early March and residents advised to monitor for 21 days after exposure. Exposure sites include Sidetrack Bar and Grill, T-Mobile in Ypsilanti, Cricket Wireless in Ellsworth, CVS Pharmacy on Michigan Avenue, plus local urgent care centers, each with specific time windows noted. Symptoms to watch for include fever, cough, runny nose, red eyes, possible white mouth spots, and the characteristic red rash that starts on the face and spreads downward. National influenza data show numerous pediatric deaths this season, highlighting concerns about vaccination gaps amid ongoing flu activity. State health officials reiterate vaccination as the best protection against preventable diseases, noting elevated flu activity with hospitalizations and multiple outbreaks. Unvaccinated individuals are at higher risk after exposure, underscoring the importance of vaccination for prevention. The Washtenaw County Health Department offers vaccination clinics with walk-in hours and provides contact details for those seeking protection. Public health guidance and vaccination information are available through the Health Department, with additional support channels such as local media for updates. Vaccination recommendations are provided with an online link to Washtenaw County Health Department resources for more information. Public health guidance also advocates preventive measures like annual flu shots, COVID-19 and RSV vaccines as appropriate, plus hand washing and staying home when unwell to curb spread. As of early March, the national context shows 1,281 confirmed measles cases nationwide, with Washtenaw County noting lower routine immunization coverage in some age groups. The infected individual is isolated at home and vaccination is strongly encouraged for those not fully vaccinated. A rare positive note in a warming world. A new study finds king penguins on several subantarctic islands showing earlier breeding and higher survival. A short-term gain as seas warm. Across about 19,000 birds, researchers observed earlier mating and roughly a 40% boost in breeding success, with Possession Island seeing chick survival rise from about 44% in 2000 to 62% today. Warmer waters are extending the breeding season there, while early breeding correlates with higher sea surface temperatures and lower plankton, signaling an unusual abundance of lanternfish that feed the chicks. The findings describe a favorable short-term outcome for a polar species, but experts caution that sustained climate change could reverse this advantage and reshape ecological competition. Scientists not involved in the study note that while penguins now appear resilient, faster climate shifts could threaten other species and alter resource dynamics, influencing winners and losers. The large-scale study highlights a shift in timing and reproduction, but near carrying capacity on Possession Island raises questions about redistribution as penguins move to other islands and colonies expand elsewhere. Experts warn the positive trend may be temporary if the polar front shifts south and food becomes harder to access, potentially leading to declines or collapse. Yet some scientists remain optimistic, pointing to the penguins' dietary flexibility, including squid, and potential adaptation that could stave off full collapse. The penguins' flexible breeding window and varied foraging strategies are cited as factors supporting resilience amid warming oceans and shifting prey. Overall, the long-term outlook hinges on oceanic food dynamics and how these shifts play out across multiple colonies. Aging-related cognitive decline in mice is linked to changes in the gut microbiome, notably a rise in Parabacteroides goldsteini that triggers gut inflammation and dampens signaling via the vagus nerve to the brain, reducing hippocampal activity and memory formation. In a Nature paper led by Christoph Theis and Mayan Levy with Timothy Cox as lead author, researchers detail a chain from gut microbes to brain function and memory, and they note funding from NIH and other foundations across multiple institutions. The study explores non-invasive ways to monitor and potentially control peripheral neurons to influence memory, highlighting that FDA-approved vagus nerve stimulation for other conditions suggests a possible clinical route, though human trials are still needed. Experimental approaches include co-housing, germ-free transfers, antibiotics, phage therapy, metabolite administration, and neural manipulation to establish causality and separate microbiome-driven effects from social factors in cognition. A broader context is provided within neuroscience and microbiome research on interoception and gut-brain communication in cognitive aging, with a News and Views piece placing normal aging's cognitive effects in a broader dementia and age-related brain change context. The article cites numerous references across disciplines, underscoring an interdisciplinary approach to understanding the gut-brain axis in aging, and notes that the content isn't original experimental data accessible without a subscription. Among specific findings, DBA mice lacking functional GPR84 show resistance to cognitive impairment induced by 3-HOA, indicating GPR84 signaling mediates effects of certain metabolites. Secreted metabolites from Parabacteroides goldsteinii, especially short and medium-chain fatty acids like 3-hydroxyoctanoic acid, can reproduce cognitive decline when given orally by dampening vagal and hippocampal activity. While the study is in mice, researchers caution that translating to humans is not straightforward due to the complexity of human gut microbiomes and species differences, and experts warn against overgeneralization. The overall message is that the gut microbiome can influence aging-related cognitive processes through specific microbial changes and metabolites, but the translation to human therapy requires careful, stepwise investigation. A new study argues that high-performance computing should be used to support integrated flood inundation modeling, not just expand simplified data-driven approaches in isolation. The authors caution against over-reliance on single-method, data-driven models and advocate blending computational power with physically informed, hybrid models for better forecasts. Published in Reviews of Geophysics on March 9, 2026, the work is a collaboration among international partners and industry players. The article, titled Synergistic Integration of Flood Inundation Modeling Methods, outlines 4 future directions: hybrid modeling frameworks, enhanced physical representation, integration of data-based methods with physics-based models, and closer bridging of science to practical policy and infrastructure use. It aims to combine strengths of different model types to create hybrid frameworks that improve realism and predictive performance. The authors envision a future where physics-based, data-driven, observational, and conceptual flood models are interconnected to advance risk assessment and response amid climate change and urban growth. They categorize flood models into 4 types, and note that data-driven methods are easier to implement but often lack robust physical constraints and generalizability. Newer data-driven approaches are efficient but limited for operational forecasting and design use due to insufficient physical grounding. A central challenge is balancing computational efficiency, flexibility, and physical realism, which has led to fragmented progress across disciplines. The study argues that integrating diverse modeling methods can improve predictions and decision-making across infrastructure design, emergency response, land use planning, insurance, water quality, and public safety, while stressing scalable, transparent, and implementable models where high-performance computing removes bottlenecks without sacrificing essential physical constraints. 2 studies using Gaia data have identified 6,594 solar twin stars within about 1,000 light-years and show an age distribution with a local peak near 2 billion years and a broad 6 to 4 billion year peak that includes the Sun, suggesting outward migration of stars from the galactic center. The findings imply the Sun was not always at its current distance from the galactic center, pointing to a major stellar migration in the Milky Way's history. Researchers propose a large-scale outward migration from the crowded center over billions of years, bringing the Sun and many solar twins into the outer disk. The results may illuminate when and how the Milky Way's central bar formed, and how a corrotation barrier could have influenced such mass migration. If confirmed, the results could constrain the epoch of the galactic bar's formation, and shed light on the Sun's birthplace and the environmental history of life-supporting planets. The Sun's current position and potential for life-friendly development may reflect broader galactic evolution rather than mere chance. Some scientists warn about sample selection biases in interpreting the broad age peak, though the team argues they accounted for distance and orbital biases, with ongoing debates on exact timescales. Outward migration may be linked to the Milky Way's central co-rotation bar, which could have concentrated gas to spur star formation and then propelled stars outward. The bar's formation, estimated around several billion years ago, may have boosted star formation and facilitated outward migration by altering stellar orbits. The research relies on Gaia and 2 mass dataset data and has support from Tokyo Metropolitan University, Japan Society for the Promotion of Science Kakenhi, and the EU Space H 2020 Explore project. This work advances galactic archaeology by linking solar twin ages to the Sun's past location and the evolution of the galaxy's central bar. The study addresses how the Sun could move outward despite the bar acting as a barrier, suggesting the barrier formed after outward migration began. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.